Hello friends, I am assi4.1 welcoming you in the solution session of assignment 4.1. This assignment is based on expansion of determinant. So without wasting time, let's go and solve some examples. In this question, we have to solve the determinant equation. So first of all, let's write down our determinant equation. And here we have x2 minus 1, 25x minus 1, 2x. Determinant is equal to 0. To get the proper equation, we have to expand our left hand side, which is our determinant. So let's expand with respect to first row. Let's write down their elements as well as space for the determinant. Our first element is x and its determinant, then minus second element 2 and its space for determinant, plus the last element is minus 1 and its space of determinant. Now to fill first determinant, which is in the multiplication of first element, we have to ignore its row and column. So first element is in first row and first column, so we have to ignore first row and first column, which will give us the small 2 cross 2 determinant 5x 2x. So let's write down 5x and 2x. Now it's time to get the second determinant, which is in multiplication of 2. 2 is in first row, second column, so we have to ignore first row and second column, which will give us 2x and minus 1x determinant. Similarly, the final determinant, which is in multiplication of minus 1, and minus 1 is in first row and last column, so ignore first row and last column, which will show us 2 5 minus 1 2 determinant, right? Now in the second step, we have to simplify this 2 cross 2 determinants, and our x will be as it is. X will multiply with 5, will give us 5x, minus 2 will multiply with x, will give us 2x. Similarly, minus 2 will as it is. Here we have to multiply x with 2, will give us 2x, minus 1x minus x. Then minus 1 will as it is, and 2 2s are 4, minus 1 5s are minus 5 is equal to 0. Now we just have to simplify. Our x will be as it is. 5x minus 2x will give us 3x. Then minus 2 will as it is. 2x plus x will give us again 3x. And finally minus 1 will as it is, and here we'll get 9 is equal to 0. Or we can say we will get 3x square minus 6x minus 9 is equal to 0. Or we can take 3 common, which will give us x square minus 2x minus 3, which have the factors x plus 1 and x minus 3 is equal to 0. So here we'll get x is equal to minus 1 or 3. Ta-da! Option A is your final answer. In our next question, we have one matrix A, AX, YA, and if XY is equal to 1, then you have to find the determinant A into A transpose. So to find determinant, first of all, we have to find A into A transpose. So let's get our A and A transpose. Here we have 2 cross 2 and 2 cross 2 matrix. So our resultant matrix will be the order of 2 cross 2. That means we will get 2 rows and 2 columns. Our first element, which is in first row first column, will be obtained by multiplying corresponding terms of first row and first column. So here A will multiply with A, will give us A square, plus x will multiply with x, will give us x square. Similarly, the next element which is in first row and second column will be ay plus xa. Let's move to the next element which is in second row first column. So we have to multiply y with a will give us ay plus a with x which will give us ax. Similarly, the last element will be y square plus a square. So we are ready with the matrix A into A transpose. Now we just have to find determinant of A into A transpose, right? So let's write down our determinant. Here we have our determinant. To solve it, we just have to cross multiply. So our first term will be a square plus x square into y square plus a square, and cross multiply again, then minus ay plus xa the whole square, right? Now it's time to open the bracket. A square will multiply with y square will give us a square y square, and a square into a square will give us a raised to 4 plus x square into y square will give us x square y square plus x square into a square will give us x square a square. Okay, now open the second bracket will give us a square y square minus 2a square xy minus x square a square. So here x square y square will cancel out, and let's put the value of x into y is equal to 1. So a raised to 4 will as it is, but x square plus y square will become 1. Then from these two terms can be cancelled out, and x into y is again 1. So here we'll get 2a square into 1, right? Sorry, here we'll get minus 2a square. So this is the perfect square, a square minus 1 the whole square. Ta-da! Option D is your final answer. The next question, matrix A is given by x1 minus x, 0 1 minus 1, x 0 7, and determinant of A is equal to another determinant. Then we have to find the value of x. So in short, we have to find determinant of this matrix A and determinant which is given and compare them to get the value of x. So fatafat, let's find out the determinant of A from the matrix. So here we have our matrix, and let's expand above first row. So let's write down the elements and space for their respective determinant. Minus second element 1 plus third element minus x and its small determinant. Now let's fill the determinant. The first element is x, so here we have to eliminate first row first column, which will give us 1 minus 1 0 7. Now the next element is 1, so we will eliminate first row second column, which will give us 0 minus 1 and x 7. The last element is minus x, so we have to eliminate first row and third column, so here we'll get 0 1 and x 0, right? Now we have to expand the 2 cross 2 determinant. X will be as it is, and we have to multiply 7 with 1, give us 7, minus 0 into minus 1 give us 0. Similarly, minus 1 will as it is in the bracket, 7 zeros are 0, minus x minus 1s are minus x, and finally minus x bracket, 0 zeros are 0, x 1s are x, right? So here we get 7x minus x and plus x square, or we can say x square plus 6x, right? Now find out the determinant of a from the another determinant, and here it is, and ready to expand with respect to first row. So 3 determinant, then minus second element 0 determinant, and plus last element 1, its determinant. Now let's fill the first determinant by eliminating first row, first column will give us minus 1, 2, 0, 3. Now the next determinant will be 2, 2 and 0, 3. And the last determinant will be obtained by eliminating first row and last column will give us 2, minus 1 and 0, 0, right? Now let's expand. 3 will as it is, 3 minus 1 is minus 3, then minus 0 2 is 0. Okay, now minus, we have 0, so no need to find the value of determinant, but still just for formality write down 6 minus 0, and finally plus 1 and 0 minus 0, which will be 0. So if you expand, you will get minus 6 and rest of the term will be 0. Oh sorry, not minus 6, minus 9. Okay, now to get our final value, we just have to compare x square plus 6x with 9. So here we will get x square plus 6x is equal to minus 9, or we can say x square plus 6x plus 9 is 0, which is actually perfect square of x plus 3, right? So here we will get x is equal to minus 3, and tada, option A is your final answer. In next question, we have one equation of determinant and we have to find the value of x. So first of all, let's get our determinants, and here they are. We just have to simplify. X will multiply with 2x will give us 2x square, then minus 8 will multiply with 4, 5 will give us 40 is equal to same thing on the right side, 3 6 are 18 minus 7 minus 2 is minus 14. Now let's simplify. Here we'll get 2x square is equal to 72, or we can say x square is nothing but 72 by 2, which is 36. So tada, x will be plus or minus 6. Option C is your answer. Let's see our next question. If there are two values of a which make a determinant is equal to 86, then the sum of this determinant is dash. So first of all, you have to find the value of a. So let's get our determinant. So let's assume it is delta. Now we have to expand the determinant with respect to first row. So let's write down their elements. 1 determinant, then minus 2 determinant, and finally plus 5 determinant. Okay, now we have to fill first determinant by eliminating first row, first column, and it will give us a minus 1 and 4 2a, right? Similarly, second determinant will fill by 2 minus 1 and 0 2a, right? And the last determinant will be a 0 4. Now we just have to simplify it. 1 will be as it is, 2a will multiply with a will give us square, then minus 4 will multiply with minus 1 will give us minus 4. Similarly, plus 2 will as it is, and 2a 2 is 4a, and 0 minus 1 will give us 0. And the last determinant plus 5 in the bracket, 4 2 is 8, and minus 0 is a 0. So just simplify and you will get 2a square plus 8a plus 44, right? Okay, now we already know that the value of determinant is 86. So here our final quadratic equation will be 2a square plus 8a minus 42 will be 0, or we can take a square 2 common. So a square plus 4a minus 21 is equal to 0, and the factor of this quadratic equation is a plus 7 and a minus 3 is equal to 0, which suggests that our two values of 7 is minus 7 and plus 3, right? But don't forget, we have to find summation of these numbers, right? So let's find out a1 plus a2. So minus 7 plus 3 will give us minus 4. Ta-da! Option C is your final answer. Here we have one interesting question. We have to solve the equation and get the value of x. So first of all, let's get our determinant. Now, by the observation, it is preferable that we have to expand determinant with respect to second row, and for that we have to select the sign of second row from the symbolic determinant format. So let's expand with respect to second row. The first sign is -1, so minus and first element p plus 1. Then the sign of second element is positive, so let's take plus and second element p plus 1 again and its determinant. And finally last sign is -1, so minus and its element p plus x with its determinant is equal to 0. Now without wasting time, let's fill its determinants. To fill our first determinant, we have to select our first element, which is in second row and second column. So here we will get 1x and x plus 1, x plus 2. Now it's time to choose the second element, which is in second row, second column. So here we'll get 1x and 3x plus 2. Similarly, the last determinant will be 1, 1 and 3x plus 1. Now we just have to expand this minus p plus 1 below as it is. Write down therefore. Okay, now we have to multiply x plus 2 with 1 will give us x plus 2, minus x plus 1 will multiply with x will give us x square plus x. Okay, now p plus 1 will as it is, and multiply x plus 2 with 1 will give us x plus 2, minus 3 is multiplied with x will give us 3x, and here p plus x will as it is, and x plus 1 ones are x plus 1, minus 3 ones are 3 is equal to 0, right? Therefore here our p plus 1 still as it is, and here x will cancel out and we are going to get 2 minus x square, then plus p plus 1 again as it is, and in bracket we will get 2 minus 2x. Here we'll get 2 minus 2x, and still minus p plus x will as it is, and the last bracket will be x 1 minus 3 will give us minus 2 is equal to 0, right? Now instead of open all the bracket, we can take p plus 1 common from the first two terms, right? So let's take p plus 1 common. So this minus will multiply within the bracket will give us x square minus 2, and from the second term we will get plus 2 minus 2x, and the last term will be as it is and is equal to 0. Okay, now here we get p plus 1 as it is. 2 will cancel out and we can take x common from the bracket. So x minus 2 minus second term is still as it is. Now as you can see, we can take x minus 2 common from these two terms, right? So here we'll get x minus 2 and let's multiply x within the bracket. So xp plus x minus p minus x is equal to 0. And after simplification, x will cancel out and take p common. So x minus 1 will remain as it is. So here we will get x is equal to 2 as well as 1. Ta-da! Option A is your answer. Now here we have a cute little question. If A is a matrix alpha 2, 2 alpha and determinant of A cube is 27, then we have to find the value of alpha. Actually, here we have to use the property of determinant, which is determinant of A cube is nothing but determinant of A's cube. So indirectly we have determinant of A is equal to 3. Okay, so let's get the determinant of A from the matrix to get our alpha. So determinant of A is nothing but alpha 2 and 2 alpha, right? Now let's simplify. Alpha into alpha will give us alpha square, then minus 2 into 2 will give us 4. We already find the determinant of A is 3. So here we can say alpha square is nothing but 7, which suggests that our alpha is plus or minus root 7. Ta-da! Option C is your answer. In this question, we have matrix P of order 2 cross 3 and Q is defined as P into P transpose. Then we have to find the value of determinant of Q. No problem. First of all, let's find out the matrix Q, which is defined as P into P transpose, and we already have matrix P, so we can easily get its transpose, right? Now here P is the order of 2 cross 3 and P transpose must be order of 3 cross 2. So here these two numbers are same and our resultant matrix will be order of 2 cross 2. That means 2 rows and 2 columns. Now let's consider first element, which is in first row, first column. So let's multiply corresponding terms of first row and first column. So 1 1s are 1 plus 2 2s are 4 and 1 1s are 1, right? Now next element will be 1 plus 6 plus 1. First element of the second row will be 1 plus 6 plus 1, and similarly 1 plus 9 plus 1. So finally we get Q as 6 8 and 8 11. Okay, but we have to find determinant of Q. No problem. Let's write down determinant of Q and cross multiply. 11 6 66 and minus 8 8s are 64. So finally we get our determinant of Q, which is 2. Ta-da! Option A is your final answer. In this question we have two determinants, delta 1 and delta 2. We simply have to find out the product of these two determinants. So first of all, let's get delta 1, and here it is. You have to multiply B with 1 will give us B, then minus A zeros are 0, so simply we will get B. Similarly, let's get delta 2. D will go with 1 will give us D minus C into 0 will give us 0. So here we get D. So simply you can say delta 1 into delta 2 is nothing but B into D. Tada! Option B is your answer. In this question, we have two determinants and we have to find the product of them. So, one by one, find their values and get the product. I would like to start with the second determinant because it looks easy one, right? So, here we have our second determinant. Let's call it delta 2, log 3 base 2, log 3 base 3, log 4 base 3 and log 4 base 3. Actually, here we have log 3 base 8. Okay, now we are ready to cross multiply. Log 4 base 3 will multiply with log 3 base 2. Then minus log 4 base 3 will multiply with log 3 base 8. Right? Now, to get the proper answer, we have to use the properties of log. First of all, we are going to use fourth property. Log 3 base 2 can be rewritten as log 3 upon log 2. Both have base e, so no need to write down it. Okay. Similarly, the second term can be rewritten as log 4, or we can say log 2 square upon log 3 minus log 3 base 8 is actually log 3 upon log 8, or we can say log 2 cube, right? Okay. And similarly, last term will be log 4, or we can say log 2 square upon log 3. Okay. Now here log 3 will cancel out, and we can say using the third property, we can say this log 2 square is 2 log 2, and log 2 will be as it is, minus here log 3 again cancel out, and this 2 log 2 square will become 2 log 2 upon this log 2 cube will be 3 log 2, right? So again log 2 and log 2 will cancel out, and we will get 2 minus 2 by 3, which is 4 by 3. Yay, we get the value of delta 2. Now thodo confidence I go delta 1 find karwa mate, right? Let's get our delta 1. Here it is, and ready to cross multiply. Log 4 base 9 will multiply with log 512 base 3 minus log 8 base 3 will multiply with log 3 base 4, right? Now it's time to use the fourth property. So we can say log 9, or we can say 3 square upon log 4, or we can say log 2 square, right? And the second term log 512, or we can say log 2 raised to 9 upon, we will get log 3, minus, it's time for the second term, log 8 can be rewritten as log 2 cube upon log 3, and similarly here we will get log 3 upon log 4, or we can say log 2 square, right? Now here it's time to use the third property. Let's apply third property, and we will get 2 log 3, then 9 log 2 whole divided by 2 log 2 and log 3 minus 3 log 2 log 3 upon log 3 and 2 log 2, right? Okay, here we can cancel out log 3 log 2 log 2, and yes, this 2 also cancel out, and remaining term is just 9 minus, in the second term log 2 and log 3 will cancel out. The remaining term is 3 by 2, right? So 9 minus 3 by 2 will give us 15 by 2. Yay, we are ready to multiply delta 1 into delta 2. delta 1 is 15 by 2 and delta 2 is 4 by 3. 2 2s are 4, 3 5s are 15 and finally 5 2s are 10. Ta-da! Option D is your final answer. In this question, you have to find area of triangle which have the vertices x1 y1 which is 7 9, x2 y2 which is 10 8 and x3 y3 which is 12 10 using the determinant. And very first step is get the D, which is determinant made up of x1 y1 1, x2 y2 1 and x3 y3 1. Let's put coordinates of the point. So here we'll get 7 9 1, 10 8 1 and 12 10 1. Let's expand with respect to first row. So 7 determinant, then minus second element 9 determinant, finally plus 1 and determinant. Now it's time to fill the determinant. First one is filled by 8 1 and 10 1. Now the second one will be obtained by ignoring first row and second column. So it will be 10 1, 12 1. The last one will be obtained by ignoring first row and last column. So it will be 10 8 and 12 10. Now just expand the determinants. 7 will be as it is and 1 8s are 8 minus 10 1s are 10. Then minus 9 will be as it is, 1 10s are 10 and 12 1s are 12. And the plus 1 will as it is, and here we have to multiply 10 with 10 will give us 100 minus 12 with 8 will give us 96. In this question, we have to find the area of triangle using determinant. We have the vertices 11 8 3 2 and 8 12. Let's call them x1 y1, x2 y2 and x3 y3. For finding the area of triangle, we have to find D, which is x1 y1 1, x2 y2 1 and x3 y3 1 determinant. Let's put the values of coordinates. So here we have our determinant. Now we just have to simplify with respect to first row. So elements of first row are 11 determinant, minus 8 determinant and plus 1 determinant. Now let's fill our first determinant by eliminating first row first column. So here we'll get 2 1 and 12 1. Okay, now for next determinant we have to ignore first row second column. So here we'll get 3 1 and 8 1. And the last determinant is filled by ignoring first row and last column. Here we'll get 3 2 and 8 12. Right, now just expand the 2 cross 2 determinants. Our 11 will as it is, 1 will multiply with 2 minus 12 will multiply with 1, then minus 8 will as it is, and 1 will multiply with 3 minus 8 1s are 8, and finally plus 1 will as it is, and 12 3s are 36 minus 8 2s are 16. Right, simplify. Here we will get 11 to minus 10 will give us minus 110. Then in next term we will get plus 40. The last term will be plus 20. It will give us minus 50. So finally our area of triangle is half mode D, or we can say half mode minus 50. So 25 square units is the final answer. Ta-da! In this question, we have to find the value of k if area of triangle is 4 square units and vertices are x1 by 1, x2 by 2 and x3 by 3, right? We know the procedure. First of all, we have to find the value of d, and next step is to put the coordinates in this formula. So we'll get 2 2 1, kk1, sorry, 6 6 1 and 5k1. Let's expand with respect to first row. So first element is 2, then space of its determinant minus second element 2 and space of its determinant, and finally 1 space of its determinant. Now let's fill our first determinant by ignoring first row and first column. So here we'll get 6 1 and k1, right? Now let's move to the second one, and we have to ignore its first row and second column. So here we'll get 6 1 and 5 1, right? And the last one will be obtained by ignoring first row and last column. So it will be 6 6 and 5k, right? Now we just have to simplify. 2 will be as it is, and 1 6 are 6 minus k 1 are k. Then minus 2 will be as it is, and here 1 6 are 6 minus 5 1 are 5. And last determinant we will get k 6 are 6k minus 5 6 are 30, right? Now it's time to open the bracket. So here we'll get 12 minus 2k minus 12 plus 10 plus 6k and minus 30, right? Which will give us 4k minus 20. So here we get our d. Now it's time to use the formula of area of triangle, which is area of triangle is half mod d, right? And we all know that area is 4 square unit. So 4 is equal to half mod. The value of d is 4k minus 20. And this mod will give us two options. 4 is equal to half 4k is 2k minus 10, or minus 4 is equal to 2k minus 10. So from the first option we will get k is equal to 7, which is your option A, and from the second one we'll get k is equal to 3, which is your option B. But the correct option of this MCQ is C, both of them. Ta-da! In this kind of a question, please don't forget, when you remove this mode, we will get two different options, plus or minus. Okay? Here we have one interesting question. You have to find possible value of A if area of triangle is 7 square units and the vertices are x1 by 1, x2 by 2 and x3 by 3. And we know the procedure. First of all, we have to find the d, which is determinant made up of x1 by 1 1, x2 by 2 1 and x3 by 3 1. So let's put their values, and we will get 5a1 minus 251 and minus 231. Now let's expand with respect to first row. First element 5, its determinant, then minus second element a and its determinant, and finally plus 1 and its determinant. Now let's fill the first determinant by ignoring first row, first column. We'll get 5 1 and 3 1. Now the next one, ignore first row, second column, get minus 2 1 and minus 2 1 again, and the final determinant will be minus 2 5 and minus 2 3. Now we just have to expand it. 5 will as it is, 1 5s are 5, minus 3 1s are 3, minus a will as it is, cross multiply, 1 minus 2s are minus 2, minus 2 1s are again minus 2, plus 1, 3 minus 2s are minus 6, minus 2 5s are minus 10. Just simplify. Here we'll get 5 in the bracket 2, then minus a will as it is, in the bracket we'll get 0 1, and within the bracket we will get 4. So as you can see, a zeros are 0, 5 2s are 10, and plus 4 will give us 14. Okay, so here the term of a is eliminated, but we have to move to the next step, which is area is equal to half mod d, or we can say half mod 14 will give us 7 square units, which is given in the question. The question seems completed, but where is a? એ તો મળ્યો જ નહીં, એ વાળો ટર્મ તો ઇગ્નોર થઈ જાય છે. તો વેલ્યુ ઓફ a કઈ પોસિબલ છે? થોડું વિચારો તો તમને ખ્યાલ આવશે કે for all a belongs to real number, our area will be 7 square unit, right? So we can say all the real numbers will satisfy this condition, but we have to choose the correct option. Here 7 4 12, all of them are satisfied our condition which is given in question, right? So correct option is D. Ta-da! In our next question, we have to find equation of line joining 2 points, x1 y1, which is 1 minus 3, and x2 y2, which is 5 minus 2, using determinant, right? So the equation of line joining these 2 points is given by determinant of xy1, x1 y1 1, x2 y2 1 is equal to 0. Now let's put the value of x1 y1 and x2 y2. So here we will get xy1 1 minus 3 1 and 5 minus 2 1. Let's expand with respect to first row. So x determinant, then minus y determinant, and finally plus 1 determinant is equal to 0. First determinant will be minus 3 1 and minus 2 1. Then the next one will be 1 1 and 5 1. And now finally last determinant 1 minus 3 5 minus 2, right? Let's cross multiply. Here we have to multiply 1 with minus 3 will give us minus 3, then minus 2 1s are minus 2, then minus y will as it is, 1 1s are 1, minus 5 1s are 5, and finally plus 1, minus 2 1s are minus 2, minus 5 minus 3s are minus 15 is equal to 0. So finally we will get minus x plus 4y and plus 13 is equal to 0, or we can say x minus 4y minus 13 is equal to 0 is the required equation of line. Ta-da! In this question we have two determinants, delta 1 and delta 2, and we have to compare them and get the correct relation. So let's find out their values and then we will compare it, right? So first of all, let's get delta 1, and here it is, and let's expand with respect to first row. So their elements will be x, then minus b, then plus b. And now let's fill the first determinant by eliminating first row first column. We'll get xb, ax, then let's move for the second determinant, and we have to eliminate first row second column, and will give us AB and AX, and similarly the last determinant AX AA. Okay, now without wasting time, let's expand. X will as it is, x into x will give us x square minus a into b will give us ab, then minus b will as it is, ax ax minus ab ab, and plus b will as it is, a into a will give us a square minus a into x will give us ax. Now it's time to open the bracket. X into x will give us x cube, then xab minus abx and plus ab square, ba square and minus abx, right? So let's simplify. X cube will as it is, and here we have minus xab x minus abx and minus abx, or we can say minus 3abx, and last two terms will be as it is. So let's write down as it is. Now it's time for finding delta 2, and it is order of 2 cross 2, so simply cross multiply x square minus ab, right? So by observation it is but obvious that option A and D are incorrect one, and for checking the B and C option we have to differentiate first determinant, right? We already have delta 1, so we can say d by dx of delta 1 is differentiation. We all know that d by dx of x raised to n is n into x raised to n minus 1, right? So d by dx of x cube will be 3x square, and 3ab is constant, differentiation of x will be 1, so here we'll get 3ab. Oh, if we take 3 common we will get x square minus ab, which is our delta 2, right? So here we get d by dx of delta 1 is 3 times delta 2. Option B is the correct one. Ta-da! This question we have f of x, which is one matrix of x lambda to lambda x. Then we have to find determinant of f of lambda x minus determinant of f of x. Okay, no problem. Here we already have f of x is equal to x lambda and 2 lambda x, right? So determinant of f of x will be determinant of x lambda 2 lambda x, right? Now we just have, so let's cross multiply. X into x will give us x square minus 2 lambda into lambda will give us 2 lambda square, right? Now we need f of lambda x, right? So instead of x we have to put lambda x. So here we will get lambda x, then lambda will as it is, 2 lambda will also as it is, and instead of x again we have to write down lambda x. So our determinant of f of lambda x will be determinant of lambda x lambda 2 lambda lambda x, right? Now just cross multiply. Lambda x into lambda x will give us lambda square x square minus 2 lambda into lambda will give us again 2 lambda square. Now we can easily find out determinant of f of lambda x minus determinant of f of x, right? Just put the values. Determinant of lambda x is lambda square x square minus 2 lambda square, and minus determinant of f of x, which is x square minus 2 lambda square. So here 2 lambda square will cancel out, and we will get lambda square x square minus x square, and just take x square common to get your final answer, which is lambda square minus 1, right? So tada, option D is your final answer. Let's see the next question. The determinant will be equal to 0 if ABC are in GP or AP or HP or none of this, and that can be found by evaluating the determinant. So here we have our determinant. Now let's expand with respect to first row, first element and determinant minus second element, its determinant, and finally plus last element, which is A minus B and its determinant. Okay, now fill first determinant by eliminating first row, first column will give us C, B minus C and 1 0. Now quickly move to the next element, which is in first row, second column. So we'll get B, B minus C and 2 0. And similarly the last determinant will be BC 2 1. Now just simplify. Our A will as it is 0, C is a 0 minus 1 into B minus C will give us B minus C. Then minus B will as it is 0, B is again 0 minus 2 into B minus C will give us 2 times B minus C plus A minus B will as it is, and 1 B is a B minus 2 C is a 2C, right? Now just open all the brackets and we will get minus AB plus AC, then plus 2B square minus 2BC, and from the last term AB minus 2AC minus B square and plus 2BC, right? Actually here we have A into C, right? This is your AC. Okay, now AB will cancel out, AC and minus 2AC will give us minus AC, then minus 2BC plus 2BC will cancel out, and 2B square minus B square will give us B square is equal to 0. Sorry, B square minus AC. So if our determinant is equal to 0, then we can say B square is equal to AC, and therefore we can say ABC are in GP. Tada! Option A is your final answer. Let's see the next question. If f of x is equal to one determinant with x ABC, then we have to find the correct option from the following options. Okay, most promising option is option C, because we have to find f of 0, right? So it's most simplest one. So let's find out f of 0. We have to replace all the x by 0. So here we'll get 0, then 0 minus A, 0 minus B, 0 plus A, 0 and 0 minus C, 0 plus B, 0 plus C and 0, right? Or we can simplify this as 0 minus A minus B, A 0 minus C and B C 0, right? Now as you can see, here we have determinant of order 3 cross 3, which is skew symmetric, right? Remember this thing, determinant of odd order of skew symmetric is 0. So we can proudly say our f of 0 is 0. Tada! Option C is the correct one. In next question, we have to find the maximum value of this determinant delta. Okay, no problem. First of all, let's get the value of delta, then we will think about the maximum. Okay, and here we have our delta. Now let's expand with respect to first row. So first element 1, its determinant, then minus again 1 and its determinant, and finally plus 1 and its determinant. Okay, now let's fill the first determinant by eliminating first row and first column. So will give us 1 plus sine theta, 1 and 1 1. Okay, now next element is in first row second column, so it will be 1 1 and 1 plus cos theta. Similarly, our last determinant will be 1 1 plus sine theta, 1 plus cos theta, and 1. Without wasting time, let's expand. Our 1 will as it is, and we have to multiply 1 with 1 plus sine theta, will give us 1 plus sine theta, minus 1 1 za 1. Again, minus 1 will as it is, we have to multiply 1 with 1, will give us 1, minus 1 plus cos theta, 1 za 1 plus cos theta, or we can say 1 minus cos theta, and plus 1 will as it is, 1 1 za 1, minus 1 plus cos theta into 1 plus sine theta will give us multiplication of them, right? Now let's simplify. First two terms will be easily simplified. We will get 1 plus sine theta. Actually 1 1 will cancel out, right? So we will get simply sine theta, and here again 1 1 will cancel out. We will get plus cos theta plus our first term 1 will as it is, and we have to open this bracket. So here we'll get 1 1s are 1, then 1 sine thetas are minus sine theta, cos theta 1s are cos theta, and finally minus sine theta, cos theta. Okay, so you can see sine theta 1 1 and cos theta will cancel out, and finally we will get minus sine theta cos theta is your delta. But we have to find the maximum value, and for that we should convert this sine cos in a single function. Let's multiply and divide by 2. So we can say 1 by 2. This 2 sine theta cos theta will become sine 2 theta. Now you have to recall the extreme values of sine. It is plus 1 or minus 1, right? And here you can observe that for sine 2 theta is equal to minus 1, we will get the maximum value of delta as a 1 by 2. So tada, option A is your answer. And if we need minimum value of delta, then it will be minus 1 by 2, right? Our next question, if alpha beta are the roots of equation 2x square plus 3ax plus 5 equal to 0. So here let's compare our quadratic equation with ax square plus bx plus c is equal to 0. So we will get a is equal to 2, b is equal to 3, and c, which is constant term, is 5. And from this we can say sum of the roots must be equal to minus b by a, or we can say minus 3 by 2, and the product of roots must be equal to c by a, or we can say 5 by 2, right? So let's find out the value of determinant. Our determinant is 0 beta beta alpha 0 alpha and beta alpha 0, right? So let's expand with respect to first row. So 0 determinant minus beta determinant, and finally plus beta and determinant. Our first determinant will be 0 alpha and alpha 0. Then next determinant will be alpha alpha and beta 0. Similarly, last determinant alpha 0, beta alpha. Okay. Now first element is 0, so no need to expand it. Minus beta in the bracket. Here 0 will multiply with alpha, will give us 0, minus beta into alpha will give us beta alpha, plus beta will as it is, and alpha will multiply with alpha, give us alpha square, minus beta into 0 give us 0. So finally minus beta into minus beta alpha will give us beta square alpha, and here we'll get beta alpha square. So we can take beta alpha common from the terms. So in first term remaining term is beta, and in second term remaining term is alpha. So let's write down the values of alpha beta, which is pi by 2, and alpha plus beta, which is minus 3 by 2, and it will give us minus 15 by 4. Ta-da! Option B is your answer. Now here we have one of my favorite question, and a solution પછી I promise તમારો બી favorite question બની છે. Here we have one polynomial on left side, ax cube plus bx square plus cx plus d is equal to, on right side we have one determinant fully filled with the x, and we have to find the value of d, right? Here you have to notice that we have to find the value of d, not x, right? And this condition, it is given in the question, so we don't have to check this condition also. So the magical step is assume the value of x, which is helpful to get the value of d, right? And most common and useful value of x is taking 0, so you can get d easily. On left side only remaining term will be d, and on right side our determinant become 0 plus 1, or we can say 1. 0 into 2 will give us 0, same thing 0, and 0 plus 3 means 3, 1, 0, and 2, 4, and minus 1. Now you can say the question has become easy peasy. Just expand with respect to first row and you will get your answer. Okay, so quickly let's write down the elements of first row and their matrix. 1 determinant, then minus 0, oh my god, 0 will helpful, then plus 0 into determinant, right? Now first determinant will be 1 0 and 4 minus 1, and rest of the determinants are just a formality, but let's follow the formality. The second determinant will be 3 0 2 minus 1, and the last one is 3 1 2 4. Now we just have to expand the first determinant by multiplying 1 with minus 1 will give us minus 1, minus 4 with 0 will give us 0. Rest of the terms will be 0, right? So your final answer is minus 1. Your D is minus 1. Option C is your answer. Ta-da! You should notice that the expansion of this determinant is quite easy, right? Because we have so many zeros. But you have to notice that this determinant is actually lower triangular, and the value of this determinant is easily found out by just multiplying elements of principal diagonal. That means we just have to multiply 1 into 1 into minus 1, and determinant is directly get as a minus 1, which you already find out, right? So use this property as a shortcut to find out the determinant of lower triangular as well as upper triangular determinant. Okay, now here we have f of theta is equal to one big determinant filled with sine and cos. We have to find the value of f of theta for all the thetas. So first of all, let's get our determinant, and here it is. To get the value of f theta, we have to expand this determinant. Let's expand with respect to first row. So the first element of the first row is cos square theta, then minus second element cos theta sin theta, and plus the last element minus sin theta. Okay, now let's fill the first determinant by eliminating first row, first column. So it will give us sin square theta cos theta and minus cos theta 0. Okay, now it's time for second determinant, and it will be cos theta sin theta, cos theta and sin theta 0. Last determinant is filled by cos theta sin theta, the sin square theta. The second row will be sin theta minus cos theta. Okay, now हिम्मत राखीन just expand करवाना try करिए. The first cos square theta will be as it is, and determinant can be solved by 0 into sin square theta will give us 0, minus cos theta into cos theta will give us minus cos square theta, right? Then minus cos theta sin theta will be as it is, 0 into cos theta sin theta will give us 0, minus sin theta into cos theta give us sin theta cos theta, and finally minus sin theta will be as it is, and determinant will be expanded as minus cos theta into cos theta sin theta will give us minus cos square theta sin theta, then minus sin theta will multiply with sin square, which will give us sin cube theta, right? Oh, बहुत बड़ा term आ गया, but हिम्मत नहीं हारवानी. Continue to expand. Cos square theta minus plus cos square theta will give us cos raised to 4 theta, then minus become plus cos square theta sin square theta, and then minus sin theta multiply within the bracket will give us plus sin square theta cos square theta and plus sin raised to 4 theta, right? As you can see, we can add the middle terms. So in next step, our cos raised to 4 theta and sin raised to 4 theta will as it is, and x plus x will give us 2x, or we can say 2 sin square theta cos square theta, right? So here you get the perfect square of cos square theta plus sin square theta. So let's write down the whole square, and we know that sin square plus cos square is 1. So tada, we will get 1 square, or we can say 1. So option A is your answer. बहुत खतरनाक હતો, but हिम्मत રાખીને expand કરો તો થઈ જાય, right? In this question, we have to find the value of summation of un, where limit of small n is from 1 to capital N, where u of n is a determinant, right? बहुत खतरनाक दिखाई दे. But if we compare this question with the sequence and series, you can say nth term is your un, and we have to find the value of sn, right? But एक नानकड़ी trick करिए. Let's find out our first term, and for that we have to assume capital N is 1. Therefore we can say small n, which is actually limit of n, right? So with which also 1. So q of 1 will be 1, 1, 5, 1 square, 2 into 1 plus 1, same thing, 2 into 1 plus 1, and 1 cube, 3 1 square, and 3 into 1, right? So here we get a simple determinant of 115, 133, and again 133. So you can expand and your answer will be 0, because here your second and third row are exactly identical. So if two rows are identical, then its determinant will be 0. So tada! Option A is your final answer.